Everyone, hi everyone, good afternoon. My name is Faizan. I hope all of you are well. In today's class, I'm going to discuss the topic called time, speed, and distance. So, a little bit about me. I have been teaching maths and also commerce courses like business studies for some years now. I've trained students for competitive exams like IP MAT and CAT and so on. So, I look forward to interacting with you today. Uh, this session is going to be divided into two parts. The first part that I'm going to talk about is some concepts, and these are important and also interesting concepts. So, the concepts that we'll discuss would be relative speed, uh, time, speed, distance, basic formulas, the idea about using the questions on a particular type of questions where you can actually use some formulas like t square is equal to t1 to t2. So that is one concept separately. There's also one more concept which is based on average speed. So maybe we'll discuss three or four concepts and we'll see for each of them, I have a question for you. So we'll probably go and see around 4 or 5 questions which are course application based, and they'll also be similar to some of the CAT questions or IPMAT questions. So this is the session that is going to be about, and we'll get started with the first topic. So I think the first topic that I want to give you an idea about is what really is the basic formulas and what is the idea of relative speed. So if I talk about the formulas, which I'm sure you all of you know, so the formulas are like distance is equals to speed into time. So I'm not writing S is speed, T is time, of course. And this is a concept that most of you, if you drive and all, you understand, right? The idea that if my speed is more and I drive for the same time, then I'm going to cover more distance. So what happens is that let's say if I use the formula for speed, it is going to be distance upon time. And if I similarly want to understand what is the formula for time, it is certainly going to be distance upon speed. So this is something that is pretty much commonsensical, which most of you would already know, of course. And if you go back to your school days, you would have also learned these formulas. What I want to tell you, of course, today is that there is a relationship, which is what I call as a direct relationship, and there is also an inverse relationship, right? So if you have done arithmetic, you would be somewhat be aware about these terms. So what happens is that imagine if you are keeping the time constant. So what happens is that you, let's say you have a bike and you are traveling for 1 hour. You have a car, you are riding for 1 hour. So if you ride at 50 kilometers per hour, you're going to travel 50 kilometers. But if you ride for, let's say, 70 kilometers per hour, right, then you're going to cover more distance. So what happens is here that distance is proportional in a direct way, which means you increase the speed, the distance will increase. But of course, there's a condition. Don't forget that time is a constant. Okay. So this is an example of a direct relationship. And I'll see there's one question that I have where we're going to come back to this later on, right? This is also used, this is very useful because if you understand it, it's going to be useful. Okay, inverse. Let's see what is an inverse relationship. Let's see this example, which is about speed and distance upon time. So what happens is, imagine if I were to keep your distance constant. So you're going from your home to your, let's say you go to swimming or you go to play some sports. So that distance is always fixed from your home. So if that distance is 2 kilometers, let's keep this distance as same. Okay. Now if I keep this distance the same, what happens if you actually increase the speed? You are going to take lesser time. So if you compare two scenarios, let's say on Saturday, on one weekend, you actually went to the sports, you went to the sports playground to play football or cricket, and it took you, let's say, 1 hour. But on the next weekend, it actually, or on the next day, like a Sunday, you actually increase your speed, and you notice that the time taken was now lesser. That is natural, of course. It's very commonsensical. But what happens in theory is that if I were to increase my speed, then it takes a lesser time, and you can represent that by this. And it is nothing but coming from this formula only. If you put subscripts S1, D1, T1, and then divide by S2, D2, T2, you are going to get this formula, right? So this is an example of an inverse relationship. Why it is inverse, as you can understand, is that your speed is impacting not distance, but is impacting your time. Okay. Yeah, so far it's good, I hope. So what do we understand from this concept? We understand these two beautiful ideas, that if you increase the distance, sorry, speed, your distance is going to be more. And with respect to speed and time, S1 by S2 will be equal to T2 by. But of course, distance is constant. Otherwise, it won't work. Okay. I'll give you one one concept on relative speed also. So this is an idea about speed, and there can be multiple questions that you will see, but those are very easy questions. For the purpose of this video, I've kept some easy to medium questions, but we're not doing very easy formula-based questions like if I'm going to if I'm increasing my speed, then how much time will I save, and so on, right? So I skipped that part, and I've coming to the idea of relative speed. Or in fact, before relative speed, I think average speed is a better idea. So so what happens is that to give you this idea, right? Suppose if I give you two scenarios. So what is happening is, in one scenario, you are covering a distance of 5 kilometers, and your speed is, let's say, 50 meter per second. Okay. So if you increase the speed to 100 meter per second, how much distance will you cover? And it is given that the time is constant, right? So this is an idea. Here you notice that this unit is not same. Okay. But even if that is not the case, you can still apply the idea of d1 by s1 is equal to d2 by s2. So this is your first scenario, which is the distance covered, and this is going to be this scenario where the speed is 100. So you can use that idea, and you can get this as 10 kilometers. Okay. One more idea could be, I mean, if you want to increase, if you want to go to school and you increase your speed from s to 2s, right? So usually you go to school with a speed of s. You increase your speed to twice. So what will happen as a result is, if usually you take 40 minutes, right? What do you think will be the time taken here in this case? So in the usual scenario, you're taking what, 40 minutes. Now you have increased the speed to twice. That means this time is going to be reduced by half. What I'm simply doing is I'm doing this idea. S by S2 is T2 by T1. And the good thing about this is that units will not matter, because units will get cancelled out, like kilometer per hour, kilometer per hour. These are going to get cancelled out. So if it is 40, it's going to be 20. 20, but of course, it's not going to be 20 seconds, it's going to be 20 minutes. Okay. Given that this is in kmph, consistency should be there. This is also in kmph. The same will hold true if this is in some other unit, but this should be in the same unit, so that they are actually they are in the similar unit. Okay. So, I mean, I wanted to skip this, but fine. Let's go to average speed. Now, average speed, I think, is something that some of you know, some of you might not know, and you will find it interesting most likely. So I have one question for average speed, and the question for average speed I will just show you. But before that, I'll give you a formula for average speed. The average speed is usually used when you are breaking your journey into two or three or more parts. So let's say you're going from one place to another. You're going from Delhi to London. You're going from Delhi to Bangalore. Anywhere, right? You break that into two parts. You went from Delhi to Dubai, and then from there to some other country. You took flight in one part, you took train in another part. So that those are the scenarios where average speed will come into play. So you will have to use this formula, which is total distance traveled. Oh, my handwriting. Total distance traveled by total time taken. So this is the formula that you have to use for average speed, and you will see that this formula is useful whenever you get questions where journey is broken into so many parts. So one more idea. The idea is that this total time taken and total distance traveled, you will have to be careful about writing this, because if, let's say, a journey is broken into three parts, then you will have to use plus plus for each of the individual parts. And same goes true for the time. You will have to find out the time taken in one part, time taken in another part, and so on. That is how you are going to be able to do this, right? So fine, let's see one example actually. I have one question, and I'll share my screen for that. So I have one question from, just give me a moment. I think there is a small problem with me sharing my screen. So I'm going to write the question over here. The question is this. So you have a square field, okay? Uh, you have a square field. Square can also be drawn better. So I'll draw a square in a better fashion. This line. Okay, so what the question says that this is a square field, and the area for this is 37.1 meter square, right? So this is a square field, and the area for this is 37.1 meter square. What you have to do is you have to find out that if a person starts his journey, and let's say for each of the individual lengths, let's say for this length, the speed is 20 meter per second. For this part, the speed is 30 meter per second. For this part, it's 40 meter per second. And for this part, it's 60 meter per second. So the person is starting from this point, and then it's going, and then he's going to come back to this point. So what is the average? The question is asking you as to what is going to be the average speed of the person during the entire journey, right? The question is asking me to find out the average speed, but it's asking me to find out during the entire journey. So what you can do really in this scenario is that you figure out how to use the formula. This is the formula that we discussed, right? Average speed. How are we going to use this formula of average speed. Remember that we discussed about using the plus signs. Okay. So take a moment and try, and then I'm going to solve it. Maybe you can pause the video, try this, and we can now solve this. Fine. So let's solve this. Look, what is total distance? And what is the total time? Let's find out. See, what is happening is in this case that this is a misleading, it serves no use. This serves no use. What you can instead do is you can take LCM of some speeds were given to you. So you can take LCM of those numbers. So this are 30, 40, and 60. And this comes out to be 120, of course. In this way, you can assume the distance to be 120. And then what happens is that for each of the individual parts, this 120 upon, I'm sorry, you can assume that one side's length as 120, sorry, because remember we have to use this plus sign. It is total distance, it is not one part. And then for each unique part, I can actually find out what really is going to be the time taken. So this is how I'm going to find out. Now it's quite simple to solve. If you add all of these, what you're going to get is 480. And I think this, if you add, is you're going to get 15, 15 or 6 plus 4, 10, 10 plus the 13, yeah, 15. And this becomes 32 meter per second. So this 32 meter per second is actually going to be your average speed. And if you notice, we have used the formula, which is the total distance, by using the symbol of plus, plus, plus across the individual parts, and we're dividing it by the individual times. That is how you understand average speed. There are some good questions in average speed, I think, but we'll not get there for the sake of being brief. We'll go to the next question instead, and we'll start with the concept, uh, a different concept, but of the same idea, of course. This is about relative speed. Now, what is relative speed? Some of you might know this already. Whenever you are comparing yourself to someone else, you're comparing your car, you're comparing your anything you're comparing, you are trying, there's the word that relatives come into place. So if you have, let's say, two cars, let's say you have car one, you have car two, they are moving. Let's say this car has a speed of 50, this car has a speed of 40, they're moving in the same direction, of course. Do you think car one will overtake car two? What do you think? If they continue to move? Because the speed of car one, which is behind car two, is actually higher, it has to overtake, it has to like meet some at some point. And this is where the idea of relative comes into place. So if we talk about the idea of relative, there will be two scenarios. This is the first case. Now, what is the first case? The first case tells me that if two or more objects are moving in the same direction, yeah, if two objects are moving in the same direction, like in this case we have car one, then the time taken is going to be the distance that is in between them divided by S1 minus S2, where S1 is of course greater than S2, because otherwise this will not work. So if it is known how much behind is car 1 from car 2, then you can actually substitute it over, let's say it's known as 30. And then I can substitute the value of 50 minus 40, and you get the idea that this is going to be 3 hours. How do you get this? So what happens is that you just put in the values of distance, the values of S1 and the values of S2. But you can also think of what will be the scenario, where will car 1 be after 1 hour. So after 1 hour, given the speed that we have mentioned as 30, it will be 30 kilometers on the right. Sorry, 40 minus 30. And the same, sorry, just a minute. Yeah. So, so what happens is that this is car one, and this is car two. So whatever the speed of car one, if the speed is 40, what happens in 1 hour? It moves that much kilometers in 1 hour. It moves that much kilometer in 1 hour. But this gap actually lessens. Why? Because this person has moved not exactly same as this person. So the gap will reduce further, it will reduce, and it will beat. That is what is happening. So it's pretty much that you observe. We'll move to the next case. The next case is okay, if I have the same two cars, car one, car two, but instead of moving in the same direction, they are actually moving in the opposite direction. So if I tell you that the distance between them is 5050, right? How much time will they take to meet? That is the question that will be interesting to understand. So for these type of questions, this distance should be known to you. And this distance is, let's say, 50 given to you. Then same thing, there is a formula time is equal to the distance between them, then S1 plus S2. This is 50 and 30 plus 20. So you get 1 hour, right? And it makes sense also. If you think of the same thing, you will see that it does happen. This moves further 30 kilometers, this moves 20 kilometers, and therefore they are actually meeting. Okay, so will be very careful about using these two cases. The first case is where you use this formula, and the second case is where you use this formula. So these are the two cases where you use the idea or concept of relative speed. I'll take a minute to halt because I want to share some questions. Just give me 2 minutes. I'm going to be sharing on my screen and we'll continue from there. Hey, so I'm back. Just a quick recap. We were discussing the concepts of average speed and relative speed. I will now share some questions that I have prepared. So, so these are the questions that you can probably see, and the questions that are here, of course, are some of them are on relative speed. So I'll go to those first. So just a minute. Yeah. Okay. Let's try this question. I have two questions which are on the idea of relative speed. So we'll try this question. This is question number 7. And the good thing about this question is that this question number 7 is on relative speed where there are three ABC. So you will have to use the concept of relative speed in this scenario as well, right? So please read this question, take a moment, pause and solve it, and then I'm going to attempt it. All right, let's see. So we have ABC that can walk at the rate of 6, 8, and 10 kmph. So that means speeds of all of three of persons are known to me. Now it is known that at 2 p.m. A starts and the speed of A is known to me. At 4 p.m. B starts and the speed is known to me. At 6 p.m. speed is known to me. Okay. Now when B catches A, what does that indicate? So what will happen is, if you look at A, the speed of A is lesser than B. That means that at 4 p.m., A must have traveled 6 into 2, 12 kilometers. Okay. And at 4 p.m., B is at 0. That means what B has to do is effectively catch up 12. And then what is the speed of B? 6, sorry, 8 minus 6. So it must take 6 hours for B to be able to catch up with A. All I've done essentially is used the concept that we discussed earlier, the concept about relative speed, where what you're doing is you're using the formula distance upon speed of B minus speed of A. So this is the idea. This is so far it is all about understanding that at what time does B catch up A. So we have seen that B is able to B is able to meet A at 10 p.m. Right? Now, if I ask you one question that at 10 p.m., what would be the distance that A would have traveled? So at 10 p.m., the distance that A would have traveled would be 8 hours into 6, that is 48 kilometers, right? Now look at this part. When B catches A, B sends him back with a message to C, which indicates that when B is able to catch A, B will be able to send him back with a message to C. Now, at this time, which is at 10 p.m., C would have traveled 40 kilometers because, of course, the difference between the time that C is starting and at 10 p.m. is 4 hours. So what is the distance between them? That is 8 kilometers. Now what you have to do is you have to be smart. Here, because A is coming back, we will use the second case of relative speed, which is 8 upon S1 plus S2. So this A is coming back. And what is S2? This has to be 10 because, C is still on the way. C is still behind, it's 40. This person's been at 48. So A plus C, we get 8 is equal to 6 plus 10, which is equal to half. So it means the solution for this question should be 10:30 p.m. Okay. I think I went a little bit slow, sorry, fast. Maybe I went a little bit fast, but all I've done is I've used the formula in the first scenario, but in the second scenario, I've used this formula. Distance is equal by speed 1 plus speed 2. So use these two basic formulas of relative speed and you get the answer, right? This is one question where you can apply the idea of relative speed. All right, let's see one more questions quickly, which is also on this concept. So we'll go to that relative speed question. Yeah, it looks like this. Okay, this is a good question. In this question, you can also use the idea that we discussed about distance being proportional to speed. Let's see this question. Please take a moment, pause, and attempt this question. All right, let's see. The question says that the person is standing here and the bus is at this point. Now, this ratio is given to be as 1:3. If you read the question, the first part of the question tells me that this person comes here and the bus comes here, that they meet over this point. And in another scenario, when the bus is able to, then the person is going to this part, then the bus is also able to meet at B. So what I will do is I will sort of tell you that why are you moving the person in the opposite? Why don't you move the person this way only? And then figure out, okay, when this bus reaches here, instead of moving this way, which is given in the question in the first part, how much, yeah, how much will this person travel? So you'll realize that, look, this part was 3 and this part was 1. And 1 unit was being covered by the person in this direction. So that means 1 unit will also be covered by the person, but in this direction. तो मतलब अभी यहाँ पे 2 यूनिट और बाकी होंगे और जब तक बस ए पे पहुंच जाएगी। अब देखो, पर्सन को बी तक पहुंचने के लिए 2 यूनिट्स बचे और बस को बी तक पहुंचने के लिए 4 यूनिट्स बचे। ठीक है, यहां तक आ गए हम। अगर हम यहां तक आ गए हैं तो हम एक चीज और नोटिस करेंगे कि ये जो बस का डिस्टेंस है ना, ये बस का डिस्टेंस ट्वाइस द डिस्टेंस ऑफ पर्सन है। अगर पर्सन का डिस्टेंस डी है तो बस का डिस्टेंस 2d है बी पे पहुंचने के लिए। तो क्या मैं ये कह सकता हूँ कि 2d/d शुड ऑल्सो बी द स्पीड ऑफ बस, बस का स्पीड बाय पर्सन का स्पीड। तो ये क्या आ जाएगा, 2:1। यही था क्वेश्चन। व्हाट आई थिंक द क्वेश्चन वाज अबाउट फाइंडिंग द रेशियो ऑफ स्पीड्स ऑफ द बस एंड द पर्सन एंड योर आंसर इज 2:1। Sorry. So these were two good questions that I thought were based on the idea of speed, relative speed particularly, and I kind of liked solving it. Yeah, we'll move to one more question that I thought is a good one. So let's see one more question. Okay, we can see this question. Please take a moment to read this question, pause it and attempt the question, and then we'll solve it. This is question number 6. Okay, let's see. So you have 3 vehicles. You have bus, you have a train, and you have a car. They're traveling from Varanasi to Kanpur, and something about their time is given to you. Okay, so let's do one thing. Let's use for speed and for time. So what we'll do is, because speed of bus and train is given to me, so we'll write 40 and 70. This is not known to me, but there's one thing that is known to me, which is that bus is taking x plus 3 and train, what is the train taking? The train 3 hours. Okay, so x minus 3 and this is x. So what I've done is, instead of writing sort of exact number is of course not known to me, but I can compare and write in this format. Now there are multiple ways of doing this. You can equate these two, get an equation in x and speed, equate these two, and then another equation. That also works. But I want to give you a shortcut, which is the idea of AP and HP. If you look at these 3 parts, x plus 3, x minus 3x, they happen to be in arithmetic progression, which means that they're reciprocals, which means speed is nothing but is a reciprocal of time, because they are traveling the same distance at the end of the day, Varanasi to Kanpur. So these speeds have to be in HP. Okay. And the beautiful formula of HP, which which is also coming from average speed, I'll just shortly give you that formula, is you can use this idea 2AB by 2A plus A by AB, 2AB by A plus B, which is like, now what is A and B? Let's see. See, this part is what? This part is your related to x, no? It is not it is not x plus 3, it is not x minus. These are not extreme values. So this speed corresponding to the time taken by car is going to be 2ab by a plus b, where a and b are speeds of bus and train. So let's write that 42, 70 by 42 plus 70. I think you're going to get 52.5. So what I've done essentially is I've used the formula of harmonic mean. We call this harmonic mean. Okay. We call this harmonic mean. And this is used when the quantities that are, I'm talking about harmonic mean for speed, right? I have got three data points for speed, and all of the three happen to be in harmonic progression. And therefore, I can use the concept of harmonic mean, which will be the middle quantity, which is 52.5. And remember, HP is because their inverse or time was in arithmetic progression. So for three data points to be in HP, it has to relate to three more data points which have to be in AP, because HP is nothing but reciprocal of arithmetic progression. So if you know this formula, this is a very simple, straightforward question, and you get the answer as 52.5. Yeah, by the way, yes, it is true that you can also use harmonic mean to find out average speed. So if you have sort of two speeds given to you over the same distance, then you can use the formula 2ab by a plus b, where a and b are the individual speeds. But remember, the distance has to be same. This also works, right? Okay, wonderful. So with this, we move to the last part. So we'll move to the last part. Let's see. Okay, so we'll move to the last part, and this last part is one question that I thought is based upon what we discussed about S1 by S2 and so on. S1 by S2 is T1 by T2 by T1. So I'll just shortly share that question with you. So that question is also in the same, yeah. This is the question that I'm going to show you. Look at the question number 5, right? So if you look at the question number 5, this is the question number 5. I'll give you a hint. Use the very beginning concept that we discussed. The concept at the beginning about finding out S1 by S2 is given by T2 by T1. When you apply this question should be able to be done. So एक बार आप pause कर लो, attempt कर लो, and then I'll go to the solution. Okay, let's see the solution. What happens here? You have one person, Akhil, starting at Hyderabad, another person, Vikrant, starting at Bangalore. They travel towards each other, right? This person goes like this person goes like this. Now, they meet at this point, of course, and the meeting time is known to me as 1 p.m., which means the person, Akhil, who was starting from Hyderabad, would have taken 4 hours. 4 hours. And this person, Vikrant, would have taken 11, 1, so it's taken 2 hours. And there's one more thing that is known to me, that when they meet, after that, what happens? So after that, till each of them meet, they go to their destination, right? That is also given to me. This person takes x plus 1 by 3 or t plus 1 by 3, whatever you may call it. This person takes x. 1 by 3, why? Because you have to convert 20 minutes, 20 by 60 is 1 by 3 hours. Okay, let's see. Can we use this? I have used that. So that, and this is basics. So you'll see that how I'm going to use this concept and then find out everything that, for example, what is the time that Akhil will take to reach the destination and so on. So I'll just quickly remove this. What happens? Let's see. So what happens is that you make S1 by S2 is equal to T2 by T1, and you get T by 4. So when you do that, you'll get T by 4. Why? Speed of Akhil by speed of Vikrant. For the first part, like for this part, from here, this is a meeting point. This person goes from here, goes here, and then this goes back. So for this part, this was 4, this was x, right? Or let's say t. So this is going to be t by 4, but only for this part, till the meeting point, from here to the meeting point. And the same thing you can apply from the meeting point to this point. For that, you will get this. Again, speed of Vikrant, 2, because this part is 2, and then this is going to be t plus 1 by 3, right? Great. So I think this should give you an idea about solving this. Look at the left-hand side. These two are same, right? If these two are same, I can equate these two. And when you equate these two, you will get a quadratic over here. And you solve the quadratic, I think the answer is going to be 8 by 3. T is equal to 8 by 3. But more important idea is that it is coming from the idea about S speed of Akhil, S1, speed of Vikrant, S2, T by 4. You can solve this question, and this is a very common CAT question as well. Uh, there's also there are more types in this, but what I've done for now is I've used this, right? And then you can get the question as well. So this is a good question. I thought it tests the fundamental concept, right? And therefore, I thought to share this question with you. Okay, what else? I I've discussed some of the questions that do come that are related to CAT and discuss some concepts. Uh, I'll show you one question from actual exam paper as well, but they are not very. If you have seen this video carefully, you will see that those questions. There are two questions that I have. They are also quite simple. Uh, I would say they are easy to medium or easy in the range. So the first question is on average speed. Let me just show you. I will not solve the question, but I'll show you the question first. So this is the question. Look at the question number 2 that you see. Take a moment, please pause and see the question number 2. It's a very simple question based on the average speed. It is an actual IPMAT question. Right? And you can also look at this question. This is also an IPMAT question. And if you read this question carefully, it should not be difficult. The only thing is that you should know that what happens in downstream is you add the stream speed, and what happens in upstream is you subtract the stream speed. And then you use the same, and then it's easy, like distance wise S plus W, distance wise minus W. These things will only give you the answer. Yeah. Right. So that is about the video. That is about the question that I wanted to show you. I hope this was a little long, but I hope you were able to listen to everything. So thank you very much. Thank you for listening. I hope to see you soon. Thank you. Bye.